Hi, thank you very much. You're welcome again. Let us look at how we can get the expression of kinetic energy lost during inelastic collision. We basically have two types of collision, that is elastic, and then we have inelastic collision. In elastic collision, the two bodies actually separate and move with different velocities after collision. And in this case, you find that kinetic energy is always conserved. So we cannot be calculating again the energy being lost when it is not lost. For the case of inelastic collision, the two bodies actually stick together and they move with what we call the common velocity. In this case, there is always some amount of kinetic energy being lost. So I want us to come out with the expression that we can use to calculate the kinetic energy by just replacing mass and maybe the velocities. How are they related in calculating the energy that is being lost in elastic collision? So here we are going to first get the kinetic energy before collision, and then we also get the kinetic energy after. Then the lost kinetic energy, we get it by saying kinetic energy before collision minus kinetic energy after collision, and that will give us the loss in kinetic energy. So we shall have before collision, before collision, we shall have two bodies of mass m1. This one is moving with u1, and then we shall have this one moving with u2, and then this is m2. Are the two bodies that is before collision. Then after collision, since the collision is inelastic, then we shall have the two bodies getting stuck together, okay? And then we shall have m1 plus m2 here, and these bodies will move with what we call bc, or what we call the common what? A common velocity. That is after the collision. So we are going to first get from the law, we are going to get the expression of this bc from law of conservation of momentum. We have momentum before collision. We have that m1 u1 plus m2 u2 is equal to momentum after collision. The momentum after collision here becomes m1 plus m2 times vc. So in this case, I can get vc, which is the common velocity, the velocity with which the two bodies will move together after they have collided. So I have to get that by saying, therefore vc itself, the common velocity, becomes m1 u1 plus m2 u2. Out of here we shall have m1 plus m2. That is how we can get the common velocity. That's the velocity with which the two bodies will move together after collision. So I am going to get kinetic energy before collision. So I can represent that by saying kinetic energy initial, I, to mean kinetic energy before collision. So initial kinetic energy would be equal to, because the two bodies are moving separately with different speeds, so they have individual kinetic energies. That will be the total kinetic energy of the system. That is before collision. So I'll have the kinetic energy of body m1 and then plus kinetic energy of body m2. So in this case, if I can factorize out the common factor, I'll have a half is common. So I'll have this is going to be m1 u1 square plus m2 u2 what? Square. So that is what we have. And then I can call this equation 1. Then kinetic energy after collision. How do I calculate it? Kinetic energy after collision, I can call it kinetic energy F, to mean final kinetic energy. So final kinetic energy, K, energy F is got by saying a half, I will have M1 plus M2 times VC what? Squared. Yes, this is the after collision, the total mass becomes this, and this is the velocity that we shall have. So we are going to have that loss in kinetic energy would be kinetic energy initial minus kinetic energy at the final stage of the collision. So we shall have loss in kinetic energy would be equal to kinetic energy, initial kinetic energy is here. I have a half, open a bracket, M1 U1 square plus M2 U2 square, and then minus final is a half. This is going to be M1 plus M2, and this is times VC squared, like that. So, but our VC is here, we can replace it. So I will have that this is going to be a half. I can have this is a half M1 U1 square plus, let me have it like this, M2 U2 square, then minus. This is going to be a half M1 plus M2 times VC. VC is M1 U1 plus M2 U2 out of, this is M1 plus M2. But this, all of it is being squared, is squared. So we shall have that this is going to be a half M1 U1 square plus a half M2 U2 square minus. This one I'll have a half, this is M1 plus M2, and then this way I'll have M1 U1 plus M2 U2, this is squared out of M1 plus M2, but also squared. So in this particular case, I will have this is a half M1 U1 square plus a half M2 U2 square, and this will cancel with one of these, so I'll have this is going to be minus M1 U1 plus M2 U2, but this is also squared out of, this will be now M1 plus M2, but I will have the 2 here, these 2, one of this will cancel one of this, and I will have that. So this, I'll get it as a half M1 U1 square plus a half M2 U2 square minus, here I can expand, this is going to be M1, let me have it as M1, this squared, U1 also squared, and then I will have plus, this is going to be, this is an addition, so I will have M2, this is M2, actually I have a square of this, then I have to multiply the 2, so it will be 2 M1 M2 U1 U2, then I also square this plus, now I will have M1 square U, no, not M1, this is M2 U2 what? Squared. This is bracketed out of 2, open a bracket, M1 plus M2. That is what we have to that stage. So I can still wrap this, I can wrap this, can have that. So when I come back here, I can have this as, I can combine the other side, loss in kinetic energy would be equal to, I will have a half 1 out of 2. So if I can add this, it is going to be M1 U1 square plus M2 2u2 square, but out of 2 minus, I'll have this is m1 square u1 square plus this is 2m1 m1 m2 u1 u2. Then I'll have plus the other one becomes m2 square, then u2 square, and then out of 2 open the bracket m1 plus m2. So the LCM of these two, we can get it. I'll have loss in kinetic energy. The LCM actually becomes 2 open the bracket m1 plus m2. That's the LCM of the two. So I'll have m1. When I say this divided by this, I'll have m1 plus m2. So I'll have m1 plus m2, and then I multiply by m1 u1 square plus m2 u2 square, then minus m1 square u1 square, then also minus 2m1 m2 u1 u2, then also minus m2 square u2 square. So when I expand this, I'll have that loss in kinetic energy. In this case, I'll have m1 multiplies that, I'll have m1 square u1 square, and then I'll have plus m1 m2 u2 square. When I multiply this and this, so when I multiply this and this, I'll have plus m1 m2 u1 square. Then when I multiply this and this, I'll have plus m2 u2, but of course this is squared, becomes m2 squared u2 squared minus m1 u1 square minus 2 m1 m2 u1 u2 minus m2 square u2 square. Then all of this is being divided by 2 open the bracket m1 plus m2. So you see that m1 u1 square will actually cancel with this one, with m1 u1 square will cancel with this and this. I'll have this should have been a square also, sorry. So you will have this is a square, so I'll have this and this will cancel, and then we will have m2 square, then u2 square will also cancel with this. Say that when I have m1 m2u, so I'll have here loss in kinetic energy becomes now m1 m2 u2 square plus m1 u1, no, this is m1 m2 and then u2, I'm seeing that is u1 square. Okay, I'll have that is u1 square. Then comes here minus 2m1 m2 u1 u2, like that. So out of 2 open bracket m1 plus m2. So in this case you see m1 m2 is common all throughout, so we can factorize it out. Still loss in kinetic energy would be m1 m2 open a bracket, I'll have u2 square plus I'll have this is u1 square minus u1 u2, actually with the 2 here. So I'll have this is 2 u1 u2. So I'll close this bracket. Out of 2 open a bracket m1 plus m2. So we can move ahead, can have this wrapped, so we can be able to complete it in a more simpler and well organized way. So I will have loss in kinetic energy. In kinetic energy will be equal to m1 m2, and then if I am to reorganize that, I'll have this is going to be u2 minus 2u1 u2, and then I'll have this is square then I will have also this is U1 but square. So this is an addition. U2, I've just reorganized this. So out of 2, M1 plus M2. So when you look at this, I can have that loss in kinetic energy is got by saying M1, M2, and then this I can have it as U2 minus U1 but squared out of 2 open the bracket M1 plus M2. This doesn't matter. Even if I came here and said U1 square, and then this way I put U2 square. Say that here you have U1 and then minus U2. Whatever I'm going to get it here, whether positive or negative, I'm going to square. That negative will disappear. So this should not worry you. So you come out, because when you expand this, you actually get this. So ideally, this is the expression for the kinetic energy that is being lost during an inelastic collision. So if you have the mass of body 1, mass of body 2, you have their initial velocities and their final velocities, their initial velocities, without even finding the final velocity, you can be able to get the kinetic energy that is being lost in the process. Thank you very much. Thanks for following.